Welcome to this introductory tutorial to Thingweb node.wot. So I am Ege Korkan, a PhD student and research associate at the Technical University of Munich, and I work on Web of Things and participate in the standardization at W3C. So let's start with why node.wot. So we know that in Web of Things, thing description hides the implementation details, and it's its goal to do so. But sometimes we get asked, but what are actually the implementation details? And more concretely, actually, how do I write a device implementation that is Web of Things compatible? Or how do I write programs that interact with Web of Things devices? Generally, we refer to this first one as thing implementations, and to the second one we refer to as consumer implementations. And we will see how they can be implemented with and without node.wot, and we will then see the differences between the two. So, how do I write a device implementation that is Web of Things compatible without node.wot? So typically you would start by choosing a protocol such as HTTP, MQTT CoAP, or in other industrial cases, OPC UA, Modbus. And generally, if you don't have concrete requirements, it's not a very easy job. Actually, you may not know from beforehand what will be your application's requirements or what will happen with the other devices. So generally, it's quite a painful process. So once you do choose one, then generally you would choose a library or framework. So with HTTP and node.js, you might choose Express.js. With Python and MQTT, you might choose Mosquito. For Python and HTTP, then you might choose Flask. And for a beginner, it's generally quite difficult to decide which one to choose, since their differences are not that obvious in the beginning. So again, it's quite a painful process. Once you do finally choose both of them, then you can program the backend. So this is what you wanted since the beginning. You want to program what happens once I get a GET request. So then maybe I should go read the temperature value and then return this value. And then this will also, of course, depend on the library and the protocol you've chosen and your programming language. And once you've done this, the more difficult part might be that you would need to write a thing description. This means that you should write a thing description that represents your implementation. And for this, you should know the thing description start quite well. And of course, you shouldn't make any mistake, because the consumers will look at the thing description and interact with the backend accordingly. So let's look at the other side. So once I want to write programs or consumer applications that interact with Web of Things devices without node.wot, and it's quite similar. So you do choose a protocol again, and then it's again quite a painful process. You don't know, and then you choose a library or framework, which actually this time is most probably different from the library or framework that you've chosen for the thing implementation. So instead of Express.js, you might use request in Node.js. Instead of Flask, you might use requests in Python, and so on. Again, it's again a rather painful process. It's the same as before. Then you can do what you wanted since the very beginning, so programming. But then this time, what does it mean to program a consumer application? It's to first fetch and parse the thing description. So again, you would need to understand the TD standard. Then you would need to program the application logic, which is basically what properties you should read and then invoke which actions. And then you should also send the correct requests. So meaning that the correct method for the correct protocol and the correct payload, and also the security requirements. You should import the credentials appropriately and use them. And for this and the last step, you should make sure that that you don't make any mistake, because these are the parts that that the device tries to respect. So the device will give a thing description, and the device will respect your requests according to its thing description. And actually, to make the matters even worse, when you choose a protocol in the beginning, hopefully the things that you will use later on, like the things you will interact with later on, hopefully they use the protocol that you've chosen in the beginning. Generally, this is not the case. So you might think of programming something that is for HTTP based things, but then you will also, of course, see some other protocol based things, and you might need to change quite substantial parts of your implementation. So how do I write now these device implementations and consumer implementations with node-wot? You just simply program the backend and you just simply program the application logic. It really is that simple. And we are able to do this since node-wot is meant for Web of Things, and it uses the thing description to facilitate all these steps. So what is node-wot? Node.wot is an open source Node.js library under the umbrella of the Eclipse Thingweb project and available at this URL. It is designed specifically for Web of Things applications, and it can be used either for Thing or the consumer side alike, and has support for multiple protocols and data formats. And importantly, it is based on the W3C Web of Things scripting API standard. It is highly modular, so that's why it can support multiple protocols, and it embraces software design patterns to provide the same programming interface for different protocols. This means that, like, if you're writing a consumer application, you will not write GET requests for HTTP or subscription for MQTT, but you will just say read property. You will just say subscribe event. You will say emit event, and so on. And all these methods will be then mapped by node-wot to the concrete protocol. So some feature list. Currently it has protocol support for HTTP, CoAP, MQTT, OPC UA, WebSockets, with more that can be implemented. And recently there was a pull request for Modbus over TCP. It has support for media types such as application JSON, so JSON and explain, and image formats to come such as SVG, JPEG, and PNG. And it supports all of the Web of Things operation types that are defined by the architecture and thing description specs. As security features that it supports, it has basic authentication, bearer tokens, API key, and PSK, with more that could be also implemented. And most importantly, it's very important to stress this actually, is that it is not an end-to-end framework. This means that a thing implementation that you write with node-wot can be used by any other Web of Things implementation or any protocol client of that protocol. So if you write an HTTP based thing, you can just use browsers to interact with it, or REST clients such as Postman or Insomnia. So there's no lock-in that sense. Okay, now let's see some action. So I will first go into some installation steps, and then we will see some code snippets and also some live coding examples. So first we will start with some simplified concepts and then go into its more advanced uses. So some installation information and some prerequisites. Like I mentioned, it's a node.js library, so you need node.js minimum version 10. Then you can see the installation requirements for Linux, Mac OS, and Windows. This also implies that it works in all these systems. So simply to install it, you can just clone the repository, change it to repository, install the dependencies, build the source code, and lastly, link the packages in a system level such that you can have the servient command available in the whole system in any directory. In case the last one doesn't work, you can replace the servient command anytime with the CLI package as listed here. And more importantly, all of the node packages are available on npm, and you can actually install via npm and not through cloning the repository. We will go into this more into detail later on. So let's use it. And for any sort of information for the functions that you will see, I will give some information, but they are all explained more concretely in the scripting API standard. And it's also good to mention that the scripting API is being standardized by the working group, and we can actually write scripts that can work in multiple implementations, and node.wot in the end is just an implementation of the standard. Okay, so for the sake of this tutorial, we will have the thing implementation. We will design a thing that allows us to control the room's temperature, for example. So it provides temperature values as property. It allows the increase or decrease the temperature via actions, and it alerts when the temperature reaches 45 degrees, such that you should, I don't know, contact the fire department, for example. So at these requirements, we can already write a thing implementation. And we have to start by describing these interactions. So we should think of a thing description like in a description. So here are the code snippets, and in the end, you will also have the full source code. So we use the what produce command, and this so we use the what produce method, and this method gets a thing description as input. So here we have some human readable metadata, and then we start specifying the interactions. So we will say that we have a property called temperature, it's an integer, and it's observable and only readable, and it has a Celsius as unit. Then we have actions. So to increment and decrement the temperature, it's very simple in this case. And they take an integer between 0 and 5 for input, and then they would add this to the desired temperature or subtract. And lastly, we have then the events, and here we have an overheat event which doesn't have any data payload, and it just alerts when the temperature is too high. So now that we have written the interaction descriptions, we actually have to program how to actually read the temperature from the internal sensor. So if I have a Raspberry and some GPIO pins that connect to a sensor, how to actually get this data into the property value, and how do I actually increment or decrement the temperature, like the physical temperature. And we also have to do some programming to have a logic that emits an overheat alert when the temperature exceeds, let's say, 45 degrees in this case. So we will have these two dummy functions. They are needed for this tutorial because I cannot show the screencast on a Raspberry, but basically instead of this random function that returns a value between 0 and 50, you would actually call the sensor's library to read the temperature. And same here, this function does nothing. It should actually um, increase or decrease or change the basically the temperature. Okay, so our important functions are the following ones. So the the property read handlers and the action handlers can be specified, and basically you specify a function that will be called when the property read request comes from a consumer. So in this case, once the property read request comes, we uh, return a promise which actually goes and calls the get temperature function. Similarly, for the action handlers, so when an invoke action request comes, for the increment, I will call this function specified here, and the value is what is coming in the input. So what we describe in the input field in the thing description, and options are other extra options such as your I variables. And increment and decrement are then very similar. And then for the event, we will have to emit the event. So the actual function is the thing that emit event, and you specify which event you will emit. And here, basically, every 5 seconds, we go and read the temperature from the temperature sensor. We write to the property, so you can always call this function to store the values internally. Then we say that if temperature is more than 45, I will go and emit an event. So then these are all the interactions we do. And then at the end of everything, you would call the thing.expose method, which actually exposes the thing in the network level. And until this function, actually, you don't have a thing implementation that can respond to requests coming over the network. Yeah, so once we do this, it is ready. So the full code the code I've shown you is fully available in this gist. But then maybe you should have noticed is that we have this what object. So if we look back, we have this object here, the what, and then everything happens thanks to this actually. So we call what.produce. But if you ever copy paste this into your editor, you might already get some complaints that this what isn't defined. And then you might be confused, but it is actually meant to be like this. So, and also the script that I'm showing that is available in this link, you cannot run it directly like node my temp controller.js. So what we need to do is to basically create this what object. So what do? We have this command that is available after installation. And this command basically builds the necessary infrastructure and creates the what object for our scripts to use. And this is what we call the command line interface of node.wot. It uses a default configuration file that can be changed to specify the security configuration protocols, static address for the generated TD, etc. And you should have noticed in the previous code examples, there were no protocol related code. It goes all through this abstraction layer. And the protocol that you actually want must be then specified in the configuration file. So let's give it a run. So now we see my IDE, the Visual Studio Code, and here I programmed all the code snippets I've shown you. So just to show a big picture of the code, you would then see sort of two parts. So one is the what produce, which is where we give the thing description, like interface, and describe the interactions. So like you see here, and like I've shown before. And then the other part where we actually specify what happens when a temperature read request comes. Basically, once the produce has finished, we are in this function here, and we can specify what should happen. So I guess this was already clear, and yeah, I just go through and the dummy functions. Yeah, and like I've shown before with the what Serbian command, we can run this. So like you see with what Serbian and then my script's name, I can run this script and it will create the what object for me. Let's do this. And it says that the temperature controller is ready. And you see that actually it even included some protocols like MQTT. And if you look into its thing description, you can also see HTTP. So in its default configuration, it puts those two functions. And you can also see that the events are emitted. Because sometimes due to this random values, it exceeds 45 degrees. Now we see the screen of Postman. So Postman is a REST client. It allows us to send HTTP, GET, PUT, and all the other requests and methods. And basically, as we said, node-wot is not an end-to-end framework, so we can just use some other consumer implementation, in this case, this REST client, to interact with the thing. So in node.wot, the TD of a thing is always found at the IP address, the port, and then the name or the title that we've given in the produce method. So once I send this request, I will get a thing description and it will be displayed like this. As you can see, we have the HTTP for different IP addresses because it puts all the IP addresses that are possible, and CoAP and MQTT. And then we can go and read the temperature. Like expected, it shows a random value, and we can increment or decrement. These are successful and they don't return anything, so they were successful requests. And then I can also do an HTTP long poll, so a GET request without the timeout. And at some point, this event will happen. So randomly, it exceeded 45 degrees, and I got my event. So that was it for the thing implementation side. And what Serbian command, we could then also explain it. So the what Serbian command uses a configuration file that looks like this. If you ever type what Serbian -h, you would see the different options. And you can also give a custom one by specifying with the -f option. And here you see some examples such as like the static address that can give, the port numbers, the broker URI for MQTT, the credentials if I need to interact with the thing that has some authentication mechanism, and so on. So how to write a consumer application that then interacts with a thing. Actually, we don't need it. So that concludes our presentation, and we can go back home. Thank you. Actually, it's not. So it is actually not needed. So like I've shown before, you can use any browser, REST client, such as Postman or Insomnia, curl, or if you have a thing with CoApp, you can use Copper for Chrome, MQTT-FX for MQTT, or Node-RED, which has actually multiple protocols. As long as they use the protocol of the thing, you can use it. Like we said, node-wot is not an end-to-end framework. So, however, you can do the consumer application way easier if you do use node-wot. And even further, the code that you write will be even protocol independent. This is possible because node-wot understands thing descriptions and it can build the requests properly. So consumer implementation starts like this. We have to specify where we find the TD. So this could be hosted on the thing, which is the case of node-wot. But it could be also stored in your computer, and then you would call it with file column / the file location. It could be in some database somewhere. It doesn't matter. And then what is important is that we again use the what object. So we have to do this. We have to use a script with the what serving command, and we consume a thing description in order to create a software object that represents the thing. So in this case, we create a temperature thing software object by consuming the thing description of it. And every method that would interact with this thing will be then called on this object. Then a basic logic we have here is that we go and read the temperature property. To do so, we call the read property method on the temperature thing. Then we can log the temperature value. And then a basic logic, we say that if the temperature is lower than 20, let's go and increment the temperature by 4. To do so, we call the invoke action on the thing. For those who are beginner to node.js, you would see that there is these async and await keywords, and they are quite important because node.js is inherently asynchronous. This means that when this line is executed without await, so when this line is executed, when the HTTP post request is sent, the code proceeds to the next line without waiting for the response. And with await, we force the program to wait until this request has finished. And to be able to use the keyword await, we have to call them in an asynchronous function, which we specify with the async keyword on the top level. And then we also can implement the event subscription. To do so, we call the subscribe event on the temperature thing object, and then we subscribe the overheat event. And here you will see that this is what happens if the event is received. This is in case of error, and this is when the subscription is finished, so in some different way. And this is called when the subscription is finished, like canceling it or the thing goes offline or similar. Again, like in the previous examples, we don't see any protocol-specific code. You can use the same configuration file, or you can specify with -c option, or with client-only true that this is only a consumer application, and just as the previous one, the full code is available. So this was the implementation of the thing, and now we will do the consumer implementation. You've already seen the code. So as you see, it's running here. I will switch to another terminal. Exactly. So here is the logic. We specify the address, we fetch the TD, we create the software object, we read temperature increment if it's lower than 20, we subscribe the event and so on. So for this, I have changed the configuration file a bit. So I just specified that it's client only. And this is how we would then specify that it's a custom configuration file with -f. We run this. And as you can see, let's just stop it. So the event has happened. So we see that we see the log statements, the room's current temperature, and we also should see the event. So the event has happened, and so like you see here, we see the actual protocol related information, but in our code, we never write protocol related information. Now let's get a bit more advanced. We won't do any crazy stuff, but we will show a bit more advanced uses of node-wot. So the most importantly is to be able to use node-wot as an npm dependency. So if you're building anything more complex than our examples, we totally recommend you to use it as an npm dependency and import it into your project code via require statements, such as this one. This means that you should not use the what-servient command, but you must build the what object yourself. Same with any npm package. You should download the node-wot packages from npm, or you can specify it in your package JSON and then run npm install and they would be downloaded. Most importantly, you should always install the node-wot core. This includes all the produce, expose, read property kind of methods. And then these are mapped to concrete protocols by using the different bindings. So you should then include minimum one binding, such as CoAP or HTTP. And this actually doesn't change the code too much. So let's see. So what we need to do is everything up to what, and let's detail what happens. So what is most important is to always include the servient. So servient is basically what includes different protocols and what different things can run on. So actually, you can attach multiple things to the same servient, and they will be just differentiated by their names. You can put different HTTP servers even that have different ports, for example. So here we include HTTP servient and HTTP, and you can always include the helpers. Then you create the servient, and then in this case we add the HTTP server by specifying the port number of the HTTP server. And then once you start it, so the servient start command returns the what object that we are already familiar with. And after that, it's just the same code as before. And here you can add multiple HTTP servers, then another CoAP server, then you could have a thing that has HTTP and CoAP at the same time. So yeah, so this is the part that is custom according to your needs. And very similarly, the consumer application, you would again start with servient. This time you would choose the client factory. So again, the HTTP. This time we actually need the helpers. And similarly, we create a servient. This time we add a client factory. So this time it's an HTTP client factory. And then we also instantiate a helper because we will need to use it to fetch. So we create a helper, and then similar to before, we give the address of the TD, and with the helper, we can fetch the TD. And then again, just as with the thing, you have to start the servient. And this happens here, you start it, and then it gives the what object. And the rest is same as before, you just call everything on the what object. So why would you do this? And so there's some extra effort involved. So there are some advantages actually. So first one is better versioning of node.wot. So when you use the what serving command, it's the same node.wot for the entire system. And by using the npm packages, you can specify the number of the version and keep the same versions. Keep different versions for different projects even. It takes way less time to install on more constrained devices like Raspberry Pis. It allows you to install only what you need. So if you don't need MQTT, you don't need to install the MQTT binding. Whereas with GitHub, all the bindings come together. It actually provides better compatibility when you combine your other npm packages, such as, let's say, reading the GPIO pins of the Raspberry through the GPIO package, or AJV for JSON schema validation. Also, then it allows your projects to be contained into one folder so that you can even copy paste this folder into other locations and you would have the whole content in there. And then additionally, it allows you to program in TypeScript. So TypeScript is a typed version of JavaScript that has like types and more object-oriented features that are more expressive. Then this actually then allows you to have more code completion and hints on variables and some assistance such as IntelliSense while programming. So I would say it has mostly only advantages. The only disadvantage is adding 4 more lines of code to your scripts, but this would then become more or less a copy-paste task. So node.wot is in the end is just a library. It's not one big project that lets you do everything. So the goal is to use node.wot in other projects, such as yours. So some node.wot-based implementations are, for example, Wade, so WOT application development environment. It's based on node.wot and provides a GUI to call different interactions. Then there is Shadow Thing, which is allowing you to do automatic reverse proxy and protocol translation, input validation, and at the same time thing simulation in a multi-threaded fashion. We also have Web of Things test bench, which allows you to test things in a black box fashion, just using their thing descriptions. There is also the WAM, WOT Application Manager from University of Bologna in Italy, which allows you to kickstart Web of Things applications by providing you an easy way to build a thing by using templates and so on. So if you have an implementation that uses node.wot and builds something even better and bigger, just let us know. We will be happy to include it in this list. So if you want to contribute, we always welcome new protocol bindings. Just a warning, when we say protocol bindings, we say actual protocols, and not protocol dialects. So What we mean is a new protocol such as AMQP, which is another broker event broker based protocol, but we would not accept the protocol such as the lightweight M2M used in IKEA thread-free lamps that is actually co-app but has some specific payloads. So we would not welcome this kind of protocols. Um, uh, we welcome bug fixes. So we identified some issues that are easy to tackle for a newcomer. So these are the issues 117, 151, and 161. And we really do encourage you to take a look at them if you want to contribute. And most importantly, I would say is that you use node.wot and you share your experience with us and submit issues when you find them and make it more popular even. Some further information and some links basically is the repository, the npm packages. Thingweb also has its own homepage as well as the Eclipse project page and some other links from W3C. So the scripting API is found in this link, the thing description specification, and also the W3C Watts homepage. So thank you very much for watching it till here. This is the end of the tutorial. If you have any questions, please contact us through our homepage or GitHub issues. And see you in another tutorial.